All right, so I'm going to go ahead and recap what we have already done on our different forms of linear functions or linear equations notes. So if you want, of course, fast forward through if you need. For those of you who were absent, we're going to go ahead and fold on these dotted lines, just like that. And the same with the purple ones. And you'll go ahead and place the white paper inside of the purple and do a couple of staples. I would suggest 2 to 3. 1, 2, and 3. Whenever you do that, you want to make sure that you get close to the edge. If you really put your stapler in there, you're going to end up covering parts that you want to be able to actually use. So I'll go ahead and take out an example here. This is one that we had already stapled, and by doing that you can see that it doesn't interfere with anything else we've written. So actually I think I'll take the ones from first period that we did not complete, because most of us got to about the same point. So that's 1. Ugh. Yeah, I should have known better. I shouldn't have used the little one. There we go. Yeah, give me a second. I'll go ahead and staple this off to the side. And that'll be 1, 2, and 3. Okay. All right. And as you can see, I can go ahead and fold it up, and I didn't really affect too much. Now, I'll go ahead and zoom in here. For those of you who were absent, we had stated that with slope-intercept form, you of course find your slope, which you guys told me was the m, the coefficient, and aside from finding your slope from there, you also find your specifically y-intercept, which is your b. And since it's going to be a number that is alone, just like we had learned last time, that will be a constant. All right. To recognize slope-intercept, you'll notice that it usually begins with either a y equals or an f of x equals, and the equivalent expression will be on the opposite side of the equal sign. There will not be any parentheses in the expression, of course, aside from the f of x. All right. Now, we left off talking about, here we go, steps to graphing a slope-intercept form. So, things that we do. There we go. We identify and graph the y-intercept, which actually here I think I might want to specify. You guys said it was a y value, but I want to be even more clear. That's the b that we talked about earlier. All right. It will be a coordinate 0, comma, number. Then we identify and use the slope, rise over run. Remember, it will go up if it's a positive number, down if it's a negative number. And just like domain, you should always move from left to right. So your denominator should be positive. I would recommend, just to avoid confusion. We use the slope to find and plot more points. So we had begun with step 1. What is my y-intercept? In the example, y is equal to 2x minus 3. I did ask you guys to be very specific, and I was told that it was parentheses. Does that show up? Kind of. 0, comma, negative 3. Okay, yeah, I guess that shows up. And we went ahead and came over to our graph and we plotted at the y-intercept, or sorry, the y-axis. 0, comma, negative 3 will be located right there. Now, slope. Slope is my coefficient. And in this case, my coefficient is positive 2. that one isn't really showing up, so I'm going to go ahead and use this. So that positive 2 can be turned into a fraction, 2 over 1. Now, since 2 is positive, I'm going to go up 2 and always to the right. So let's go ahead and do that right now. I'm going to go up 1, 2 units, and 1 to the right. And I'll continue going up 2 to the right 1 until I, well, run out of space. Now, I've run out of space going from left to right, but I can always continue. So I can also go backwards. So I'm going to say here, or. If I were to go backwards, that means I am going to do the exact opposite of whatever I had here. So since I went up 2 last time, I'm going to go down 2 units. 1, 2. And then last time I went to the right 2 units, so this time I'm going to go to the left 1 unit. So down 1, 2, and then to the left 1. And again, continue until you've run out of space. Because this is an equation, I can go ahead and conectar con un línea y flechas. Yeah, you're welcome. And that's it. We just finished graphing a slope-intercept form equation. There we go. Got a little bit more light on it. All right, let's go ahead and move on to the next one. Point slope form. Alrighty. Point slope form. Obviously, we will find our slope. Now, notice I'm using the same colors. I just want to try and keep things uniform. I want the colors to represent something. So, last time my slope was represented with an M. Well, it's still represented with an M. Perfect. Okay. But this time with point slope form, not only am I given a point, or I'm sorry, not only am I given the slope, but I'm also given, yeah, I gave it away, a point. So I'm going to go ahead and color that one in pink. Hopefully this one shows up. There we go. That shows up. Now my point is going to be consisting of these numbers here. The x sub 1 and the y sub 1. So let's go ahead and break this down just the same way. I'm going to be working backwards. So we already discussed that M there we go. Just as before, it's still the slope. Of the equation. Or you could also say of the line, because we already know this is a linear function. Okay, but in comparison, now we have to deal with this point. Now this is the really important part that a lot of people get confused, and that's really why I want you to pay attention to the color. Let's see, let's get a little bit of light on there. All right, so your point will still be a coordinate. So, parentheses, x, and we've already talked about these subscripts here, x sub 1, comma, y sub 1. And yeah, that's probably going to bleed through the other side. Oh, well. Okay, so x sub 1 comma y sub 1, this is the given point or coordinate on the line. Now, this point, it isn't necessarily an x-intercept or a y-intercept. It's simply a a random point at this time, and from there you can continue using it to build up your line. So recognizing point slope form. There we go, recognizing point slope form. First and foremost, x and y. This is a main one. X and y are on opposite sides of the equal sign, to be more specific. Okay. Either x is in parentheses or y is not by itself, or both are happening. All right, so either x is going to be in the parentheses, y might have something with it, or both of them are happening, just like we have on the bottom, okay? So let's go ahead and continue. So here I gave you here we go, an example. Now, we're going to go ahead and list through how we would approach this. So, just like before, let's go ahead and talk about the steps to graphing a point slope form equation. So, step 1. We would graph the given point. Now, remember, this point is the same one I was talking about below, so I'm going to keep it in the same color. Boop, boop. There we go. I'm talking about x sub 1, comma, y sub 1. There we go. After that, so that's kind of our starting point. Step 2, we would use the, that was an E, sorry, slope. Now, last time, whenever we were talking about slope, it was very simple, very basic. We said rise over run. I'd like you guys to think a little bit harder this time, all right? With the slope, here we go. I'll go ahead and bring it in orange again. Rise over run, oh, come on, that's easy stuff, all right? What's another way to describe rise over run? Another way to find the slope. I'm sure some of you guys should be able to tell me this one. That would be the equation to find slope. Some of you guys write this in backwards, but I'm going to write it the correct way. Y sub 2 minus y sub 1. Ah, yes. Some wheels are turning. X sub 2 minus x sub 1. Now, do recall, just as before, it'll go up if it's positive, down if it's negative, and of course, you should always move to the right. It should be positive on your denominator. Another way you could think of this would also be the change in y. It's changing because we're finding the difference, or delta y over delta x. All right. Now, we find the slope, and just like before, we use the slope to find and plot more points. There we go. All right, so seems fairly simple. Let's go ahead and identify. Now, this is the tricky part, and you do have to be able to identify these things. So I'm going to go ahead and start with the easy one, my slope. So my slope, as I saw last time, let's bring it up right here. Oop, there we go. My slope is going to be, again, a coefficient. It's in front of the parentheses, though, in front of the parentheses with x. So I found parentheses with an x. There you go. So my slope was pretty easy to locate here. There we go. All right, so -2. Let's turn that into a fraction, -2 over 1. Since it's negative, I'm going to go down. My 1 is positive, so I'm going to move to the right. All right. Now the point. Oh, goodness. This is where everybody kind of messes up. So what I'd like you to do is go ahead and write the point slope form that we have written at the bottom part. I want you to write it right above here. And I'm going to go ahead and use some color while I'm doing this. Of course I am. So the equation that we have all the way down here, I'm going to write it above the given equation for the example. And it says y minus, I use my color, y sub 1 equals, I think maybe I'll draw these kind of boldly. There we go. M parentheses x minus x sub 1. Now, the reason I wanted you guys to do this is because I want you to see it lined up. Okay, so let's maybe zoom in for my blind little bats. There we go. Okay, so y minus minus y sub 1 is lined up with 3. So I've got part of my point. I'm going to put parentheses. I'm going to put a blank because I don't know the x sub 1 yet. But I know that this lines up. My y sub 1 should be 3. Now it's at x sub 1. Let's go ahead and go locate that one. So as we're continuing, the equal signs line up. My m lines up with -2, and yeah, that was the easy one that we got at the beginning. My parentheses line up. My x's line up. This is kind of strange. My equation should have another minus sign, but here I have a plus sign. Interesting. This kind of brings up what we had written on the back of page 1 of your notes. Well, we were talking about multiplying integers. If I wanted to change this plus sign to include a minus sign, how could I possibly do that? How can I get a minus sign to be equal to a plus sign? Well, one of the main things that we had discussed on the back of page 1 was that a negative times a negative is a positive. So, keeping that in mind, I could probably do this. And I know you're going to hate me for doing this. I'm evil. I'm going to use my white out here. Tell me if this is the same or not. What if I were to put down my subtraction symbol? Let's turn that into a bracket. And then say that this were negative 1. So if I were to do that, because a negative times a negative equals a positive, my x's line up, my subtraction lines up, and now my x sub 1 lines up, and it's in fact negative 1. This is going to be the most difficult part about doing slope-intercept form, is identifying the correct point. If they're both negative, then this number is all you have to worry about because they line up. Now that I have my negatives lined up, now my x sub 1 lines up too. Okay, now that we have that, the rest is easy peasy lemon squeezy. So let me go ahead and zoom back out, move over a little. There we go, maybe a little bit more. All right, so we're going to graph the point. Negative 1, which is on the x-axis, and then positive 3 on the y-axis would be right here. Again, I'm going to follow my slope. I'm going to go down 1, 2, and to the right 1. All right, down 2 to the right 1, and I'm going to again continue until I run out of space. What would be the way to go backwards? The opposite would be going, rather than down, we're going to go up 1, 2. And the opposite would be to the left. Ta-da! Okay, there we go. Sorry, I was making sure. I thought I had drawn that incorrectly. All right, so let's go ahead and connect that up. Please do not forget to put your arrow. That is super important. I did do it wrong. Oh no, goodness me. I knew it looked kind of off. Tell you kids, Dollar Tree, they have whiteout. There we go. I make mistakes all the time. See, I made another mistake. All right, there we go. So we have our point. Make that a little bit bigger here. And we used our slope. And now we're able to get a couple more things, like now I can see my y-intercept. I can approximate my x-intercept. And actually, I'd like to talk about those on our next and final fold. So go ahead and open it on up. And we're going to work with standard form. Ba-ba-da-ba. All right, so standard form. Let me try and find some colors that will show up. I think I will use purple. I'm going to steal one of you guys' highlighters because I have a feeling they'll show up. Purple and green. Why not? All right. So, actually, I'll leave those off to the side for right now. We're going to start a little differently, so make sure that you're paying attention to this part. This is the only one that we're going to start a little differently. So recognizing standard form. There we go. Recognizing standard form. All right. So standard form. X and Y are on the same side. Of the equal sign. And that's kind of different from before. Okay, so you'll notice X and Y, they're right there. Ah, just like I said. Okay, next, sorry. The coefficients notice this time they're capital letters. A and B, the coefficients of x and y are integers. This one is super important. Now, in case you're like, I know that this is page 5 of my notes, but I still kind of forgot what integers are. Shame, first off. But it's fairly simple. Integers are positive and negative whole numbers. Okay, all right, not too bad, not too bad. And lastly, all right, so these numbers are going to be whole numbers of some sort, positive or negative. X and Y are on the same side of the equal sign. And lastly, there is a constant. There is a constant. Obviously, it's the only one we have left there. C on the other side of the equal sign. Okay. Whew, that was a lot. All right, so we're going to talk about graphing this. Now, this is going to be the one that you're going to use the most. You have seen it your freshman year, or sorry, back in Algebra 1, and you're going to see it again. This is going to be the main one. So first option to graphing this standard form is to convert. We're going to convert to slope-intercept form. The easy peasy y equals mx plus b. Okay. So that's one option. Option number 2, we would have to find and solve for, sorry. Find and solve. Oh, I guess I shouldn't have put and. Oh well. Find, solve for, then graph the x and maybe I'll make that a little bit darker. And y intercepts. All right, now, time for that color, right? So first off, in order to find the x-intercept, so I'm going to go ahead and color this one in purple. Does it show up? Not really. I guess I should have gone with the darker one. Might be a little too dark, but hey, why not? Oh, actually no, I think that was just perfect. All right, so for the x-intercept, I'm going to keep it in purple here, and I'm going to write it over here. To find the x-intercept, I'm going to abbreviate, feeling lazy. We are going to substitute, oh, wow, everything that we've been doing, it's coming full circle. We're going to substitute 0 for y and solve. All right. Now, obviously, if I'm finding the x-intercept, you're solving for x. Okay. I know it kind of seems a little silly for me to have to specify that, but you never know. And then we have the y-intercept. I'll go ahead and put that in green here. Y-intercept. Let's see if that will show up. Nope, not showing up. I'm going to go ahead and use a darker pen. There we go. So the y-intercept, it's the exact opposite. We will substitute, again, 0 for x and solve. Oh, okay. So let's go ahead and give this a shot. Now, this is going to be a lot more algebra. I hope you're ready, and then that's it. We're done, okay? Okay. Option 1, we're going to convert to slope-intercept form. This is something that a lot of you guys have trouble with. So I'm going to use the following example. Oh, it's right up here. All right. So here we have 2x minus 3y equals 6. If I want to get to slope-intercept form, my goal is to get y equals mx plus b. That means y is alone. Okay, so let's go ahead and we'll write it out. So we're going to start with 2x minus 3y equals 6. Now, we've been dealing with order of operations. Now, whenever you are solving, you use the order of operations, but you go backwards. Order of operations is only whenever you are trying to simplify a numeric expression, okay? So here, since I'm trying to solve for something, we're going to go the opposite direction. So, first and foremost, we want to see if we can add or subtract. And just in case, I'll go ahead and put this up here. It would be what I like to call SAD MEG. That would be subtraction, addition, division, multiplication, exponents, and then grouping symbols. Okay? All right. So, do I have, and sorry, since my goal is to get y alone, that's going to be the last thing I move, okay? Do I have anything that I can remove using subtraction or addition? Well, yeah, of course I do. As a matter of fact, I have this 2x. And I mean, take a look. The x should be on the opposite side. So since this is a positive 2x, I'm going to use the inverse operation and subtract 2x. Now, we were talking about this equal sign being a balance beam. Whatever I do on one side of the equal sign, I must do on the other. Now, this 6 doesn't have an x, so I could say that they are not like terms. So I'm just going to put this off to the side because I don't want to combine them. All right. 2x minus 2x, well, that's our yellow word, elimination. It becomes a big fat 0. So I can pretty much drop everything down now. I'm going to say I have negative 3y equals 6 minus 2x. Okay. Now, if I wanted to get this y alone, I would have to use the opposite operation once again. But the difficult part here is trying to figure out what operation is occurring right now. It seems that there is this implied multiplication happening here. So again, the inverse for multiplication would be division. Since it's being multiplied by negative 3, I will divide by negative 3. And well, I do the same thing to the other side, to all of its terms. Now, negative 3 divided by negative 3 is our blue term. It would reduce to 1. Now, speaking of reducing, 6 divided by negative 3 could also reduce. So let's go ahead and write this out. I'm left with y equals, well, a positive divided by a negative would give me a negative again, and that reduces to 2. But a negative divided by a negative equals a positive. That would be a positive 2/3 x. Now, for those of you who are nitpicky, of course, this isn't in the proper order. You could switch that around and say y equals 2/3 x minus 2. That is mx plus b. And just like we had done previously, we would identify our slope followed by our y-intercept. So in order to graph this, we would say my b is 0, negative 2. And my m would be 2 up, 3 to the right. But since we've already done an example of graphing slope-intercept form, I'm not going to do that yet. I want to show you how to graph using the x and y intercepts. So I know, I'm sorry that this is a little lengthy. We're almost done. We're in the home stretch. So let's go ahead and start with my x-intercept. Now, do you recall an x-intercept is a coordinate, should always be in parentheses. My x value will be first, followed by a 0. That's how you can recognize an x-intercept. So let's go ahead and begin. We're going to take the same equation, 2x minus 3y equals 6. Substitution. Oh, actually, sorry. We're going to substitute my y value. Duh, hello. So just like we've been substituting for the past few weeks, my 2x is going to stay there, but my 3y, my y is going to be substituted using a 0. Now, I personally love to do this because anything times 0 is, well, 0. So it makes it really easy to get rid of stuff, to eliminate things. So my negative 3 times 0 is 0. Now, this is something that I know I probably shouldn't say, but if it helps you remember, listen up. There was a teacher at my other school that would say, we could simply, let me write this down somewhere. Choose a different color. We can simply hide and divide. Oh man, and that makes it so simple if I follow this rule. So if I want to find my x-intercept, well, I really don't care about my y. I could literally hide it. Okay, so I'm going to keep that hidden there because what I did by substituting, I bring down just 2x equals 6. And obviously, to get my, grab a pen here. Oh, here we go. To get my x alone, just like I did over here, I'm going to do the inverse operation on both sides and divide by 2, leaving me with, let's see here, there's my purple, x equals 3. So therefore, oops, not x, silly, 3, 0. So the hide and divide, if I want to find my x-intercept, I hide the opposite and I divide by my coefficient. And that makes it really easy. So I'm going to go ahead and plot on my x-axis 1, 2, 3, 0. Beautiful. Okay, well, scooch that up a little. If I were to do the same thing, and now this time we're going to find my y-intercept. Remember, a y-intercept would look like, that's the y-axis, y-intercept would be parentheses, the opposite, 0, comma, and the y value. Okay. Now, we'd be using the exact same equation, but this time, what I would try and hide would be my x. I really don't care about it. And just the same, I would do 2, and I'm going to substitute, my x value with 0, and then minus 3y equals 6. So I hide and divide. Oh, I love this because just as before, that eliminates, left with negative 3y is equal to 6. Last step, divide by the coefficient. And, well, y equals negative 2. So therefore, my y-intercept would be 0, comma, negative 2. And I would plot that over here on my y-axis. Oh, there we go. Now you can see that. 0, negative 2. Now, usually I would say just grab a straight edge and connect up your line. But some of you guys want to really make sure that you have your points. So I'm going to kind of zoom into that right there. Go and zoom in a little bit more. Okay, so I noticed that if I pay attention to the slope, which is the same as I got up here, I went up 2 and to the right 3. So if you really wanted, you can continue that slope, and I can go the opposite, which is, well, down 2 and to the left 3. So down 2 to the left 3. This is really helpful, especially whenever you don't have a straight edge, or whenever students roll up your flexible rulers and it doesn't give you a straight edge. Cough, cough. There we go. Done. All right. Whenever you guys return, we will be practicing doing this. If by chance, if not, it's okay. We'll probably do it in class. You're probably thinking, how the heck is this supposed to go into my notes? It's not hole punched. How was I supposed to know they were notes? I get you. Don't you worry. So this is what we would do. Here we go. So usually I would either get a piece of notebook paper or a piece of scratch paper. If it's a piece of scratch paper, make sure that it's hole punched. So I'm going to use a warm-up that got messy. All right. So notice that it has stuff on it. Do I care? No, not really. Because I'm simply going to take this and my little stapler, and I'm going to put 1, 2, I'll bring that down a little. There we go. And then I'm going to open it up. This is where it can be a little bit more difficult. I need to get us some more staplers, the big ones. 3, and then 4. And it'll staple in so that it looks like this in your notebook. So you can easily flip through. You can either have it going this way. I know some of you guys don't like whenever the folds are going this way, so you can do it the opposite and have this part over here. But we'll go ahead and do that in class unless you already have notebook paper and a stapler or tape. I wouldn't suggest glue because these staples might end up giving you trouble. But I'm going to go ahead and staple mine on, and this will be page 8. Alrighty, thank you guys. Make sure that you finish this up. These are a grade. Bye.